An important property of merge sort is that it's typically not an in-place sort. Okay, so as you see now, when looking at these, I do not really swap them, but I write them to somewhere else in the memory. And similarly with 1 and 4, I write them here. And with these two sublists, 2, 5, and 1, 4, I write them here. Okay, so typically you need extra memory in your computer to execute merge sort apart from the memory slots that your data came in. So typically this is not an in-place sort, but there are variations on merge sort that actually are in place. But the usual definition of merge sort usually is not in place. Another recursive sort algorithm is the famous quicksort algorithm. I say famous because it has become the almost de facto standard for sorting algorithms, and it has been implemented in several programming languages and several libraries and several operating systems. So it's used very widely, and rightly so, because as the name suggests, it's quick. And I'm not going to go into the details of that at this point, but it on the average at least performs better than most other algorithms. So how does it work? This is my input. Now again, if the input size is 1, I just return the list as it is, because I don't need to do any sorting in this case. But if that is not the case, what I do is I select the pivot element among this list. Now the selection of this pivot element is important because it affects the performance of this algorithm, and early implementations used either the leftmost element or the rightmost element, but we now know that selecting this randomly actually gives a better performance. So in implementations, usually you do not select the pivot from either extreme of the sequence, you select it randomly. So it's equal to a sub k, 4 sub k. It's just one of the values in your list. Okay, so what you do is you partition your sequence into 2 groups such that one group, list 1 here, has the smaller values, well, values that are smaller than your pivot element, and the other list, list number 2, has the elements that are greater than the pivot element. So using the pivot element, you actually, let's say you have this sequence and you select some pivot element here. You whatever is here, if they are less than the pivot element, they need to go here. And in this place, if you have any elements that are greater than the pivot element, they need to go here. Okay, and then inside these 2 portions, you apply quicksort once again recursively. Okay, so return quicksort of list 1, so that will give you a sorted list here. And then you put the pivot in between, and then you put the quicksort applied to the second list here, which will come as sorted. So the output will be sorted. As I said, selection of the pivot affects the performance. And typically, we can say that quicksort is in place. Of course, it depends on the implementation.